66 million years ago, a space rock 6 miles wide slammed into Earth and erased the dinosaurs from existence. But what if something else walked this planet before us? What if an entire civilization rose, built cities, split atoms, and vanished without a trace? Scientists call this the Silurian Hypothesis, and it suggests we might not be the first intelligent species to call Earth home. We'll journey through deep time, explore how civilizations disappear, uncover the signatures advanced life leaves behind, and discover why finding ancient aliens might be impossible. Make sure to like and subscribe, because what we're about to uncover will change how you see our planet forever. The investigation begins now. Imagine if every human on Earth disappeared tomorrow morning. Our cities would stand empty. Skyscrapers would pierce the sky like steel monuments to our existence. Roads would stretch across continents. Nuclear power plants would dot the landscape. You might think these traces of our civilization would last forever, marking our presence for any future intelligence that evolved to find them, but you would be wrong. Time moves differently when you measure it in millions of years. What seems permanent to us becomes temporary on geological scales. Your house will crumble in decades. Your city will erode in centuries. Even our greatest monuments will succumb to the relentless forces of wind, rain, and shifting continents. Consider this shocking reality. In just 10,000 years, most evidence of our sprawling civilization would vanish. The pyramids would weather away. Mount Rushmore would collapse. Our concrete highways would crack and crumble into dust. Nature would reclaim everything we built with unstoppable persistence. Think of it like writing your name in sand on a beach. The letters look clear and permanent when you first carve them, but each wave that rolls in erases a little more. The wind blows away the sharp edges. Soon, only faint indentations remain. Then nothing at all. This is exactly what happens to civilizations over deep time. Earth's surface constantly recycles itself through processes that make our construction projects look like sandcastles. Tectonic plates slide beneath each other, dragging entire continents down into the molten depths. Mountains rise and fall, oceans expand and shrink. The very ground beneath our feet gets recycled every few 100 million years. But here's where the mystery deepens. If our own advanced civilization would vanish so completely, how could we ever hope to find evidence of previous ones? We're not just talking about stone tools or pottery fragments. We're investigating whether entire technological civilizations could have existed millions of years before humans evolved and left no trace whatsoever. The numbers are staggering when you really think about them. Earth is 4.5 billion years old. Modern humans have existed for only 300,000 years. Our industrial civilization spans barely 300 years. That means we've used technology for just 0.06% of Earth's total history. What happened during the other 99.94% of our planet's existence? We assume nothing intelligent walked this world before us, but that assumption might be the biggest mistake in human history. The geological record preserves only tiny fragments of the past. Most of what happened simply disappears forever. If another species developed technology millions of years ago, their cities would have crumbled to dust. Their plastics would have decomposed, their metals would have rusted away. Even their bones might have dissolved in acidic soil. Yet some signatures of advanced civilization might survive in ways we never expected. The question becomes where to look and what clues might remain hidden in the rocks beneath our feet. Because if we're not the first, the evidence must be somewhere. But what if we flip the question around completely? Instead of searching for ancient civilizations, what if we examine our own? What traces will we leave behind for future archaeologists to discover millions of years from now? The answer reveals just how difficult finding previous civilizations really becomes. Our cities will vanish, but our chemistry will remain. Every day, we pump billions of tons of carbon dioxide into the atmosphere. We've fundamentally altered the chemical composition of our planet's air in ways that will echo through geological time. Future scientists will see this spike in atmospheric carbon preserved in ice cores and rock layers like a smoking gun. The isotopic signature of our fossil fuel burning creates a unique fingerprint. Coal and oil contain carbon that's been locked away underground for millions of years. When we burn these fuels, we release carbon with a distinctive chemical signature that differs from natural carbon cycles. This signature will persist in the geological record long after our smokestacks have rusted away. Think of it like adding food coloring to a swimming pool. Even after the water has circulated thousands of times, sensitive instruments can still detect traces of the dye. Our industrial emissions work the same way. They permanently stain the chemical composition of Earth's atmosphere, oceans, and rocks. But the most shocking footprint we'll leave behind is nuclear. Every atomic bomb we've detonated, every nuclear power plant we've operated, creates isotopes that don't exist naturally on Earth. Elements like plutonium-239 have half-lives of 24,000 years. These artificial isotopes will persist as clear evidence of nuclear technology long after human civilization has crumbled. We're also creating entirely new materials that have never existed before. Plastics represent a completely novel class of molecules. Some plastic compounds can persist for hundreds of thousands of years without decomposing. Future geologists will discover thin layers of plastic debris embedded in rock formations like archaeological evidence of our throwaway culture. Consider the scale of our impact. We've moved more Earth through mining and construction than all the world's rivers, volcanoes, and glaciers combined. We've created artificial channels that redirect entire river systems. We've built structures that fundamentally alter how sediment flows across continents. Even our extinction pattern tells a story. We're currently driving species extinct at rates 1,000 times faster than natural background extinction. This mass extinction event will show up clearly in the fossil record. Future paleontologists will see a sharp drop in biodiversity that coincides exactly with all our other industrial signatures. Yet here's the terrifying part. Despite all these dramatic changes we're making to our planet, most of our technological infrastructure will still disappear completely within a few million years. The chemical signatures will remain, but the actual artifacts of our civilization will vanish. This means any previous civilization would face the same fate. Their cities would crumble, their tools would rust, their bones would dissolve. But if they were advanced enough, they might have left chemical fingerprints in the rocks. The challenge becomes learning how to read those ancient signatures buried deep in Earth's geological memory. Here's a question that will blow your mind. Why can we find the bones of a Tyrannosaurus rex that died 66 million years ago, but we would completely miss an entire technological civilization that existed just 10 million years ago? The answer lies in understanding just how rare fossilization really is and how the geological record plays favorites with different types of evidence. Fossilization requires incredibly specific conditions that almost never occur. Your body needs to be buried quickly in sediment before it decays. The chemistry has to be perfect for minerals to replace your bones. The rocks containing your remains must avoid being heated, crushed, or eroded for millions of years. When you calculate the odds, fewer than 1 in a billion organisms ever become fossils. But here's the crucial difference. Dinosaurs lived for 165 million years across the entire planet. Billions upon billions of individual dinosaurs died during that time span. Even with terrible preservation odds, sheer numbers guarantee that some fossils survive. It's like buying lottery tickets. Buy enough tickets over enough time, and eventually you'll win. Now imagine an advanced civilization that lasted only 1 million years. Their total population might have been just a few billion individuals total. Their bones would face the same terrible fossilization odds as ours, but without the massive numbers that guarantee some preservation. The mathematics work against them. The situation gets worse when you consider where civilizations tend to live. We build our cities near coastlines, rivers, and fertile valleys. These locations provide access to water, transportation, and resources. But these same areas experience constant geological activity that destroys evidence over time. Rivers flood and change course, burying some areas while eroding others. Coastlines shift as sea levels rise and fall. The sediment that might preserve artifacts gets washed away or redeposited elsewhere. Urban areas sit in geological zones that actively work against long-term preservation. Think about this shocking reality. The oldest human city we've discovered is only about 9,000 years old. Anything older has been completely erased by natural processes. If our own cities disappear so quickly, how could we expect to find cities built by other species millions of years ago? The fossil record also has enormous gaps. Paleontologists estimate we've discovered less than 1% of all species that ever lived. Entire geological periods contain almost no fossils at all. Millions of years of Earth's history remain completely blank in our understanding. Most fossils come from creatures that lived in specific environments where preservation conditions were ideal. Ocean bottoms, swamps, and river deltas provide the best fossilization conditions. But these environments rarely preserve the types of locations where advanced civilizations would build their cities and infrastructure. We're essentially trying to solve a puzzle with 99% of the pieces missing. The few pieces we do find create a distorted picture that favors certain types of evidence while completely ignoring others. This means we could be surrounded by traces of ancient civilizations and never recognize them. The evidence might be hiding in plain sight, preserved in ways we haven't learned to detect yet. Deep beneath Antarctica's ice sheet lies a frozen library of Earth's atmospheric history. Every year, snow falls and compresses into ice, trapping tiny bubbles of ancient air. These ice cores contain the actual atmosphere from hundreds of thousands of years ago. Scientists can extract these bubbles and measure the exact chemical composition of air that dinosaurs breathed. But they also reveal something else entirely. Starting around 1850, the ice cores show a dramatic spike in carbon dioxide levels. This spike coincides perfectly with the beginning of human industrial activity. The fingerprint of our coal-burning civilization is permanently etched into the ice, creating an unmistakable signature of technological development. But ice cores only preserve the last few 100,000 years of atmospheric history. For older periods, we need to look at rocks. And here's where the story gets interesting. Rocks can preserve atmospheric signatures for hundreds of millions of years through processes that work like chemical time capsules. When ancient plants grew, they absorbed carbon dioxide from the atmosphere. The specific isotopes of carbon they incorporated depend on the atmospheric composition at that time. When these plants died and turned into coal or organic-rich rocks, they locked away a sample of ancient atmospheric chemistry. Scientists can analyze these rocks and reconstruct what Earth's atmosphere looked like millions of years ago. The technique reveals natural climate cycles, volcanic eruptions, and asteroid impacts. But it could also reveal the signatures of previous industrial civilizations. An advanced civilization would alter atmospheric chemistry in distinctive ways. Burning fossil fuels create specific isotopic ratios. Industrial processes release particular combinations of gases. Nuclear technology produces unique radioactive signatures. These chemical fingerprints would persist in the geological record long after the civilization disappeared. The challenge is learning to recognize artificial signatures versus natural ones. Earth's climate system produces some extremely unusual events on its own. Massive volcanic eruptions can pump more greenhouse gases into the atmosphere than human civilization. Asteroid impacts can alter atmospheric chemistry for thousands of years. But there are telltale differences. Natural events typically show gradual changes or sudden spikes followed by gradual recovery. Industrial signatures tend to show sustained, accelerating changes that follow technological development patterns. The isotopic ratios also differ in ways that suggest biological versus geological sources. Consider this mind-bending possibility. Some climate anomalies in Earth's past might actually represent the signatures of previous civilizations. Unexplained spikes in atmospheric carbon, unusual isotopic ratios that don't match known geological processes, rapid climate changes that happen too fast for natural causes. The Paleocene-Eocene thermal maximum, occurred 56 million years ago. Global temperatures spiked by 15 degrees Fahrenheit in just a few thousand years. Massive amounts of carbon entered the atmosphere from an unknown source. The event nearly sterilized the oceans and drove many species extinct. Scientists blame volcanic activity or methane releases from the ocean floor. But the speed and scale of the carbon release pushes the limits of what natural processes can accomplish. Could this represent evidence of a previous civilization that industrialized too quickly and triggered catastrophic climate change? The possibility seems far-fetched until you remember we're currently conducting the exact same experiment with our own planet's atmosphere. In 1945, we split the atom and changed Earth forever. Every nuclear weapon we've detonated leaves behind a radioactive signature that will persist for millions of years. These artificial isotopes don't exist anywhere else in nature. They represent clear, undeniable evidence of advanced technology, and they accumulate in the geological record like a permanent archive of nuclear activity. Plutonium-239 has a half-life of 24,000 years. Even after 1,000,000 years, detectable traces would remain in the rocks. Cesium-137 persists for hundreds of years. Strontium-90 contaminated the entire planet after atmospheric nuclear testing. These isotopes get incorporated into plant tissues, animal bones, and sedimentary rocks. Future geologists will discover a thin layer in the rock record that contains artificial radioactive materials. This layer marks the exact moment when one species on Earth developed nuclear technology. It's like a geological signature that says, "Intelligence was here," in letters written with atoms themselves. But here's the terrifying question. What if similar layers already exist deeper in the geological record, waiting to be discovered? Natural nuclear reactions are extremely rare on Earth. Uranium ore sometimes achieves critical mass underground and sustains nuclear fission for thousands of years. These natural reactors create some of the same isotopes we produce artificially, but the signatures look different under careful analysis. Artificial nuclear reactions produce specific isotope ratios that differ from natural ones. Weapons-grade plutonium has a distinctive isotopic fingerprint. Nuclear power plants create waste products with characteristic signatures. Even nuclear medicine and research reactors leave behind unique traces. A previous civilization with nuclear technology would scatter these artificial isotopes across the planet. Nuclear accidents would create local contamination hotspots. Nuclear waste disposal would concentrate radioactive materials in specific geological formations. Nuclear warfare would spread distinctive isotopes globally through atmospheric fallout. The half-lives of these materials vary dramatically. Some isotopes decay completely within decades. Others persist for millions of years. A sufficiently advanced civilization might have produced nuclear materials with extremely long half-lives that we haven't discovered yet or don't recognize as artificial. Consider this chilling scenario. Deep drilling projects sometimes encounter rocks with unexplained radioactive signatures. Usually, we attribute these to natural uranium deposits or geological processes. But what if some of these signatures represent the nuclear waste disposal sites of civilizations that existed millions of years ago? The search for these signatures faces enormous challenges. Radioactive materials concentrate in specific locations rather than spreading evenly through rocks. You might drill 1,000 holes and miss the evidence completely. The signatures also get diluted over time as radioactive materials disperse through groundwater and geological processes. Even more disturbing is the possibility that we've already found evidence and misinterpreted it. Unusual isotope ratios in ancient rocks get explained away as natural phenomena or measurement errors. We expect to find natural explanations, so we don't seriously consider artificial ones. The nuclear signatures represent perhaps the strongest possible evidence for previous technological civilizations. Unlike cities or artifacts, radioactive isotopes can't be explained by natural processes or misidentified as something else. They scream technology to anyone who knows how to read the atomic fingerprints. Yet we've barely begun to search for these signatures in Earth's deep geological history. Every piece of plastic ever manufactured still exists somewhere on Earth today. That bottle you threw away last week will outlast you, your children, and your children's children. Plastic doesn't biodegrade the way organic materials do. Instead, it breaks down into smaller and smaller fragments that persist in the environment for hundreds of thousands of years. We've created a permanent marker of our civilization that future archaeologists will find embedded in rock layers around the globe. Scientists call it the plastosphere. This new geological layer contains billions of tons of artificial polymers that have never existed before in Earth's 4.5 billion year history. Polyethylene, polystyrene, and polyvinyl chloride represent entirely novel molecular structures that no natural process can create. The signature is unmistakable. These synthetic molecules have specific chemical bonds and isotopic ratios that differ completely from any biological or geological material. A future civilization analyzing rock samples would immediately recognize these compounds as artificial. They're like alien chemistry embedded in Earth's geological record. But plastics represent just the beginning of our materials revolution. We've created thousands of synthetic compounds that don't exist in nature. Synthetic rubber, artificial fibers, industrial chemicals, and pharmaceutical compounds all leave distinctive molecular fingerprints in the environment. Consider the scale of this chemical contamination. We produce over 400 million tons of plastic every year. Most of this material ends up in landfills, oceans, or scattered across the landscape. Microplastics now contaminate the deepest ocean trenches and the highest mountain peaks. They're incorporated into the tissues of every living organism on Earth. When these plastics finally get buried under sediment and compressed into rock, they'll create a geological layer unlike anything in Earth's history. Future paleontologists will discover rocks containing artificial molecules and know immediately that an advanced civilization existed when these layers formed. This raises a profound question. If we're creating such obvious artificial signatures, shouldn't we be able to find similar signatures from previous civilizations? What artificial materials might ancient technologies have developed? A civilization that existed 50 million years ago would have had different technological pathways than ours. They might have developed biological manufacturing instead of synthetic chemistry. They could have created artificial materials that we don't recognize as technological products. Their waste streams might look like natural deposits to our current understanding. The challenge becomes recognizing artificial signatures that don't match our own technological development. We search for nuclear isotopes and plastic polymers because that's what our civilization produces. But what if previous civilizations developed completely different technologies that leave entirely different signatures? Imagine a species that mastered genetic engineering instead of mechanical engineering. Their cities might have been grown rather than built. Their materials might have been biological rather than synthetic. Their waste products might look like natural organic deposits rather than obvious industrial contamination. Or consider a civilization that developed nanotechnology millions of years before us. They might have created materials with atomic-level precision that we can't distinguish from natural crystals or minerals. Their technological signatures might be hidden in plain sight within rock formations we consider completely natural. The plastic layer proves that advanced civilizations leave permanent traces in the geological record. The question isn't whether evidence exists, but whether we know how to recognize it when we find it. Earth has experienced 5 major mass extinction events that wiped out most life on the planet. The most famous killed the dinosaurs 66 million years ago, when an asteroid 6 miles wide slammed into Mexico. But the other 4 remain mysterious. Something triggered catastrophic die-offs that eliminated up to 96% of all species. The causes range from volcanic eruptions to climate change to unknown factors that scientists still debate. Here's a disturbing possibility we rarely consider. What if some of these extinction events were caused by previous civilizations? Advanced technology carries enormous risks. We've developed weapons capable of sterilizing the planet. Our industrial activity is triggering the 6th mass extinction right now. Climate change from fossil fuel burning threatens to collapse entire ecosystems. Nuclear warfare could render Earth uninhabitable for thousands of years. A previous civilization might have faced the same technological challenges and failed to solve them. They might have triggered runaway climate change, polluted their environment beyond recovery, or destroyed themselves through warfare. The extinction event would eliminate the civilization while also erasing most evidence of their existence. Consider the Permian-Triassic extinction that occurred 251 million years ago. This event nearly ended life on Earth completely. 96% of marine species and 70% of land species disappeared forever. The oceans turned acidic. Global temperatures soared. The atmosphere filled with toxic gases. Scientists blame massive volcanic eruptions in Siberia that lasted for thousands of years. These eruptions pumped enormous amounts of carbon dioxide and sulfur compounds into the atmosphere. The resulting climate change triggered a cascade of environmental disasters that nearly sterilized the planet. But the scale and speed of this extinction pushes the limits of what natural processes can accomplish. The volcanic explanation requires perfectly coordinated eruptions across vast areas for thousands of years. Some researchers suggest additional factors must have been involved. What if those additional factors included industrial pollution from a previous civilization? A species that developed fossil fuel technology millions of years before us might have triggered catastrophic climate change. Their industrial emissions combined with natural volcanic activity could explain the unprecedented scale of the Permian extinction. The timing becomes even more suspicious when you examine the pattern. Most mass extinctions show rapid environmental changes that happen faster than geological processes typically operate. Something seems to accelerate natural disasters beyond their normal intensity. We're currently conducting a real-time experiment in triggering mass extinction. Human activity is driving species extinct at rates 1,000 times faster than natural background extinction. Our carbon emissions are acidifying the oceans and destabilizing global climate systems. We're following the same trajectory that led to previous mass extinctions. This creates a terrifying feedback loop. Civilizations develop technology, trigger environmental collapse, and get eliminated along with most other life on Earth. The geological record preserves evidence of the extinction but erases traces of the civilization that caused it. Future intelligent species evolve, develop technology, and repeat the same deadly cycle. Mass extinctions might represent the ultimate filter that prevents civilizations from becoming truly advanced. They develop dangerous technologies, lose control of their environment, and destroy themselves before they can spread beyond their home planet. The question becomes whether any civilization has ever been wise enough to break this cycle and survive their own technological adolescence. 2.5 billion years ago, Earth's atmosphere contained almost no oxygen at all. Then something remarkable happened. Oxygen levels began climbing steadily until they reached 21% of the atmosphere. Scientists credit this transformation to cyanobacteria that evolved photosynthesis and began pumping oxygen into the air as a waste product. But the details of this process reveal some puzzling anomalies that don't fit the standard story. The rise in atmospheric oxygen wasn't smooth or gradual. Instead, oxygen levels fluctuated wildly throughout Earth's history. Sometimes they spiked to 35%, creating an atmosphere so rich in oxygen that giant insects could evolve. Other times they plummeted to less than 10%, nearly suffocating most complex life. These dramatic swings in atmospheric composition require explanations beyond simple biological evolution. Something was actively managing Earth's atmospheric chemistry in ways that natural processes struggle to accomplish alone. Modern industrial civilization dramatically alters atmospheric composition through fossil fuel burning and industrial processes. We reduce oxygen levels in localized areas through combustion and manufacturing. We also produce oxygen through industrial electrolysis and chemical processes. Our net effect on global oxygen levels depends on the balance between these competing influences. A previous civilization with different technologies might have affected atmospheric oxygen in distinctive ways. Industrial processes that consumed enormous amounts of oxygen could create temporary depletions preserved in the geological record. Advanced manufacturing might have required atmospheric modifications that left chemical signatures. Consider the late Ordovician extinction that occurred 445 million years ago. This event eliminated nearly 85% of marine species in two separate extinction pulses. Scientists blame glaciation and falling sea levels, but the atmospheric evidence tells a more complex story. Oxygen isotope ratios in rocks from this period show unusual patterns that don't match typical glaciation signatures. The isotopic evidence suggests rapid changes in atmospheric and oceanic chemistry that happened too quickly for normal geological processes. Something was actively altering the composition of Earth's atmosphere and oceans. The isotopic signatures could represent evidence of atmospheric engineering by a previous civilization. Advanced technology might have required specific atmospheric compositions for manufacturing or energy production. Terraforming projects could have intentionally modified atmospheric chemistry for biological or technological reasons. Even more intriguing are the carbon isotope anomalies found throughout Earth's geological history. These signatures indicate periods when the normal carbon cycle was disrupted by unknown processes. The disruptions show patterns that suggest intentional rather than random changes to atmospheric chemistry. Natural processes typically create gradual isotopic changes that follow predictable patterns. Biological evolution produces specific isotopic signatures that match known metabolic processes. Geological events like volcanic eruptions create distinctive chemical fingerprints that scientists can easily recognize. But some isotopic anomalies don't match any known natural process. They suggest artificial manipulation of atmospheric chemistry through processes that don't exist in nature. The patterns look more like industrial signatures than biological or geological ones. We might be looking at the atmospheric management systems of previous civilizations preserved in rock chemistry. Species that achieved planetary scale technology might have deliberately modified Earth's atmosphere for their own purposes. Their atmospheric engineering projects could explain some of the most puzzling chemical signatures in the geological record. The evidence suggests Earth's atmosphere has been artificially managed multiple times throughout its history. Deep beneath the ocean floor lie structures that challenge everything we think we know about geology. Massive geometric formations stretch for hundreds of miles in perfectly straight lines. Crystalline structures display mathematical precision that seems impossible for natural processes to create. Rock layers show evidence of extreme heat and pressure applied in patterns that don't match any known geological phenomenon. Most of these anomalies get explained away as unusual but natural formations. Geologists assume that given enough time, natural processes can create almost any structure. But some formations push the boundaries of what natural forces can reasonably accomplish. Consider the Richat structure in Mauritania, known as the Eye of the Sahara. This massive circular formation spans 30 miles in diameter and consists of concentric rings of different rock types. The structure is so perfectly circular and precisely organized that it's visible from space. Geologists believe it formed through erosion of a geological dome, but the mathematical precision seems almost too perfect for random natural processes. Similar circular and geometric formations appear throughout the geological record. Some show evidence of artificial modification or construction that natural processes cannot explain. Underground chambers with smooth walls and precise angles suggest technological rather than geological origins. The challenge lies in distinguishing between unusual natural formations and genuine artificial structures. Earth's geological processes can create remarkably complex and organized patterns through purely natural means. Crystallization, erosion, and tectonic activity sometimes produce structures that look artificially designed, but certain features point toward technological origins. Uniform composition across vast areas suggests industrial manufacturing rather than natural deposition. Precise geometric patterns indicate mathematical planning rather than random natural forces. Evidence of extreme heat or pressure applied in specific patterns suggests technological processes. Underground mining operations would leave distinctive signatures in the geological record. Tunnels and chambers carved through solid rock would preserve their shape for millions of years if properly sealed. Extraction of specific minerals would create characteristic patterns of missing material that don't match natural geological processes. Large-scale construction projects would also leave permanent traces. Foundations excavated into bedrock would remain visible long after surface structures disappeared. Artificial modifications to river courses or coastlines would show up in sedimentary records. Even road construction would create linear patterns of compressed earth that persist for geological time periods. The most intriguing possibilities involve mineral formations that seem too pure or too organized for natural processes. Some rock layers contain unusually high concentrations of rare elements arranged in patterns that suggest artificial concentration or refining. These formations might represent the industrial waste or byproducts of previous civilizations. Certain crystalline structures show evidence of artificial nucleation or growth control. Natural crystals typically form through random processes that create irregular shapes and sizes. But some ancient formations display the kind of uniformity and precision that suggests technological control over crystallization processes. We might be surrounded by the archaeological remains of previous civilizations without recognizing them as artificial. Our geological training teaches us to explain unusual formations through natural processes. We don't seriously consider technological explanations because we assume no previous civilizations existed. This bias could blind us to obvious evidence of ancient technology. Structures that clearly show signs of artificial construction get reinterpreted as unusual but natural phenomena. We might need to completely rethink our approach to geological interpretation. The evidence might be hiding in plain sight, waiting for someone willing to consider impossible explanations for impossible formations. Scientists have begun the most audacious archaeological project in human history. Instead of digging for pottery and tools, they're searching for the technological signatures of civilizations that might have existed millions of years before humans evolved. This new field combines geology, chemistry, and archaeology to hunt for evidence that previous intelligence once walked this planet. The search focuses on technosignatures that no natural process can create. Artificial isotopes that only nuclear technology can produce. Synthetic molecules that require industrial chemistry to manufacture. Atmospheric signatures that indicate large-scale technological activity. Geological formations that show evidence of intentional construction or modification. Researchers are developing new techniques to detect these ancient signatures. Mass spectrometry can identify artificial isotopes in rock samples with incredible precision. Chemical analysis can distinguish between synthetic and natural molecular structures. Isotopic dating can determine when unusual atmospheric events occurred. The challenge lies in knowing where to look. Earth's surface has been recycled countless times through geological processes. Most evidence from millions of years ago has been destroyed through erosion, subduction, and mountain building. Only certain locations preserve ancient materials intact. Deep ocean sediments offer the best preservation conditions. The ocean floor accumulates layers of sediment that preserve atmospheric and chemical signatures for hundreds of millions of years. These sediment cores contain detailed records of Earth's environmental history, including any technological signatures that might exist. Ancient salt deposits also preserve environmental conditions with remarkable fidelity. When ancient seas evaporated, they left behind chemical records of atmospheric composition and environmental conditions. These salt formations can preserve evidence of industrial activity or atmospheric manipulation from previous civilizations. Ice cores from Antarctica extend the atmospheric record back nearly 1 million years. While this timeline doesn't reach deep enough to detect truly ancient civilizations, it provides a template for recognizing technological signatures in older geological records. The most promising approach involves systematic searches for statistical anomalies in the geological record. Natural processes follow predictable patterns that scientists understand well. Technological signatures would show up as deviations from these natural patterns that require artificial explanations. Early results from this research remain inconclusive but intriguing. Some geological formations show unusual chemical signatures that don't match known natural processes. Certain atmospheric anomalies in the deep geological record suggest artificial rather than natural causes. But none of these findings provide definitive proof of previous civilizations. The scientific community remains divided on whether any evidence actually exists. Most researchers believe natural explanations can account for all observed anomalies. They argue that geological processes are more complex and variable than we currently understand. But a growing minority suggests we should take the possibility seriously. The mathematical probability that Earth could have supported previous civilizations is actually quite high. The geological evidence for detecting such civilizations is admittedly weak, but that doesn't mean they never existed. The search continues with new technologies and expanded sampling programs. Deep drilling projects are extracting rock cores from previously inaccessible depths. Advanced chemical analysis is revealing isotopic signatures that were impossible to detect just a few years ago. Within the next decade, we might finally answer one of the most profound questions in human history. Are we the first technological civilization to evolve on Earth, or are we following in the footsteps of previous intelligence that rose and fell millions of years before us? The answer will fundamentally change how we understand our place in the universe. We stand at a crossroads between two radically different versions of reality. In one version, we are Earth's first and only technological civilization. We represent the pinnacle of 4.5 billion years of evolution, the first species to split atoms, explore space, and contemplate our own existence. We are alone in our cosmic journey, carrying the entire responsibility of intelligence forward into an uncertain future. In the other version, we are merely the latest chapter in a much longer story. Previous civilizations rose and fell across the vast expanse of geological time. They developed technologies we can barely imagine, altered Earth's climate and atmosphere, and ultimately vanished into the archaeological silence of deep time. We are following ancient footsteps down a path that has been walked before. The evidence suggests the second version might be closer to the truth. Chemical signatures in the geological record point toward artificial manipulation of Earth's atmosphere. Isotopic anomalies hint at nuclear technology from millions of years ago. Mass extinction events show patterns that match technological rather than natural causes. Geological formations display mathematical precision that pushes the boundaries of natural explanation. Yet none of this evidence provides definitive proof. The signatures remain ambiguous enough that natural explanations cannot be completely ruled out. We might be seeing patterns where none exist, finding artificial explanations for phenomena that have purely natural causes. But the very possibility changes everything. If previous civilizations existed, they faced the same challenges we confront today: climate change, resource depletion, nuclear weapons, and environmental collapse. Some might have solved these challenges and transcended to become spacefaring civilizations. Others might have failed and triggered their own extinction. The pattern suggests a fundamental test that all technological civilizations must pass. Can they develop advanced technology without destroying themselves? Can they manage their planetary environment responsibly? Can they avoid the catastrophic mistakes that lead to civilizational collapse? We are currently taking this test ourselves. Our industrial civilization is altering Earth's climate faster than any previous change in the geological record. We possess weapons capable of sterilizing the planet. We are driving species extinct at unprecedented rates. The next few decades will determine whether we pass or fail the same test that previous civilizations might have faced. The Silurian Hypothesis reminds us that technological advancement comes with profound responsibilities. We are not just advancing human knowledge and capability. We are participating in an ancient cosmic experiment to see whether intelligence can survive its own success. If we succeed, we might join a community of advanced civilizations that learn to transcend their planetary origins. If we fail, we become another mysterious layer in the geological record, leaving behind chemical signatures that puzzle the next species to evolve intelligence. The choice is ours to make, but we might not be the first to face it, and we probably won't be the last. The question that will define our species remains unanswered. In a universe 4.5 billion years old, are we pioneers or merely the latest attempt at consciousness trying to find its way home? Subscribe to join us as we continue exploring the deepest mysteries of our cosmic story.